Welcome everyone to the third video of the series, the integral of the day. Now, the integral that we want to solve today is the integral of the square root of 1 plus x squared dx. It is a very short integral to write, but it is a little tricky to solve, I would say. Why don't you try to do it on your own, pause the video, and when you're ready, or when you want to see the solution, continue the video, please. Okay, I assume that you want to see the solution. So let's do it. The way that we want to tackle this is, I will first of all get rid of the square root because it makes everything more complicated and, well, overall it makes it complicated. Yeah, that's it. There is no end, okay. So how can we get rid of this? Well, if you have done a little bit of practice with trig substitution, you can immediately see that one way to handle this is by letting x equal tangent of theta. And so if you take the differential on both sides, you're going to have dx equaling, what is the derivative of tangent of theta with respect to theta? That is secant square of theta. Then you have d theta. Okay? And we also know that, this is very common knowledge, I think. This is Pythagorean identity for trigonometric functions. We know that sine squared theta plus cosine squared theta equals 1. If you divide both sides by cosine squared, on the right you will have secant squared theta, and on the left you will have tangent squared plus 1. Tangent squared theta plus 1. Okay? So if we make this substitution, what will happen? Well, we still have the integral sign, and then we have the square root. We have 1 plus x is tangent squared, right? So I put tangent squared theta. And if we take this is going to be secant squared theta then. And if you take the square root of that, you would get normally plus or minus secant of theta. But due to the way that we limit ourselves to, so due to the domain that we're dealing with while we take these integrals, you will in fact don't need to, you won't put the plus or minus, okay? I don't know if this is explanatory enough, but if you have problems with this, please write in the comment section and I will try to provide a more in-depth explanation on why we don't put a plus or minus. But this is just secant of theta, okay? We take the square root of the square. Secant of theta, we would write dx normally, but let's just switch to d theta because we now have a variable in terms of theta. Our variable is theta now. So we're going to have secant squared theta d theta, right? Which basically means that we have, well, I want to write it as secant cubed because we don't need it, okay? This is what we have. And how can we take this integral? It looks like it even got more complicated. Well, in fact, there is a way out. And that way out is using integration by parts. So the way we handle it is by doing this. And if you don't know integration by parts, I have a video about it. I will attach to the descriptions part and also to the cards. Okay, so you can access them from both of those places. And basically, as I explained in that video that I will attach, we can call this dv and this u. So if that is the case, well, let's do it with orange again. So u is secant theta, which means du is, derivative of secant theta is secant theta, tangent theta, d theta. And if we assign dv as secant squared d theta, if we take the integral on both sides, v is going to be tangent of theta. You could put a constant plus c, but you don't need to for the method to work, okay? So I won't put. And so this is what we have, yeah. And, well, if we continue here, the formula basically tells us that you will have u times v. So tangent theta, secant theta, and then a minus an integral of duv. So v du. So I put the v tangent theta. And then I will put the du, which is here. So we in fact have tangent squared secant theta d theta. Okay? Now let's continue. Let's continue. And I will continue it. I will kind of like separate these. I will continue here. So we have tangent theta secant theta minus. For tangent squared, I will make a substitution using this. So I will substitute secant theta minus 1 secant theta d theta. And so if I now distribute the multiplication, we will have tangent theta secant theta minus the integral of secant cubed of theta d theta, then a minus minus, so that's a plus integral of secant theta d theta. Okay? And I made it, this is a 3. Let's not confuse it, that's a 3. And here, you might notice a very interesting thing. Look at this. On the left, we have the integral of secant cubed theta. And on the right, we have this. And it involves secant cubed of theta's integral, the thing that we're looking for. So if I add this integral to both sides, what will happen? Well, on the left, we will have 2 secant cubed of theta integral d theta, right? On the right, minus and plus, they cancelled. That's why we in fact added an integral of secant cubed d theta to both sides. To leave us with this, tangent theta secant theta plus integral secant theta d theta. Okay? And if I divide through by 2, we can say this. Okay. And this is useful because remember, the substitution that we made allowed this integral to equal the initial integral that we're trying to find. So this is in fact still equal to this thing that we're trying to solve. All right? And so, I mean, after this, it is a lot easier actually. We have 1 over 2 tangent theta secant theta plus the integral of secant theta d theta. Well, I mean, you might even know this from memory. I know it from memory, but if you don't, here is how you do it. Here is how you do it. You multiply it by this factor, which is basically 1, because you can simplify. This is 1. So if I distribute it, I'm doing this step quickly. If you need to understand how this works, please go ahead and stop the video and think about it. This is not multiplication, there is plus here, sorry. Secant theta plus tangent theta d theta. And as you can notice, the derivative of the bottom appears in the top, on the top. Derivative of secant theta, right here. Derivative of tangent theta, right here. And if you have the derivative of something divided by that thing, and that is inside the integral, I know that was a funny way of saying it, but I hope you understood me, that gives you ln, the natural logarithm. So this integral is in fact ln of the bottom part, which is secant theta plus tangent theta. And the absolute value is here to ensure that we don't plug in a negative value for ln, because that is out of domain for the natural logarithm function. We will put a plus c here, right? Because it's an indefinite integral. But you can just take the plus c out of the parentheses because, well, because if you do it like this, you will distribute the 1 over 2, so the constant becomes c over 2, which is still a constant, so you can define it to be a new constant, c1, let's say. But let's just not write the subscript c1, so that's just c. And we're not done here. There is a little step that we need to take, and that step is to switch back to x. We can do it by using this right triangle. So, well, maybe I should do it on a new page, why not? So the result is, for this integral, we found it to be, let's try to write it from memory. I will check though if it's right or wrong. But I think I remembered it correctly. Let's see. Yes, I in fact did. So we also said that x was equal to tangent of theta, right? That's right here. One of the first things that we did. Which means that we can draw a triangle, a right triangle, to solve the problem. If we say this is theta, tangent is opposite over adjacent. So this is x, this is 1, and the hypotenuse, that's just Pythagorean theorem, 1 plus x squared under the square root. So the result is going to be, you have the 1 over 2, and then secant of theta, well, let's just write it actually. Secant of theta, that is opposite over the adjacent, so that's just 1 plus x squared under the square root over 1, which is just the square root of 1 plus x squared. And tangent of theta, well, we actually wrote it here. It's right here. So the result is going to be, and we don't have the integral anymore, sorry. There is no integral. The result is, I put the tangent first, it doesn't matter though, plus ln, let's put the tangent again first. 1 plus x squared plus c. And that is the result for the integral that we wanted to solve. And if you don't trust me, and which you should not do, I mean, obviously we did the method. It appears to be correct. It is correct because we didn't do any calculation mistakes. But at the end of a problem like this, there were lots of steps. So you might be wondering whether or not you did a mistake. To ensure that the answer that you got is right, just take the derivative of this with respect to x. You should get this. If you don't get it, well, then you did it wrong. Okay? So I would say just take the derivative of this. We could do it in this video, but I don't want it to take too much time. But that's it. I hope you found this video helpful. If you have any questions, please ask them in the comment section. And I hope to see you in another video. I hope for that you subscribe. But anyways, take care.